Okay, while they're getting mic'd up, let me just let me introduce Venki, who can then introduce the others. Venki is the ultimate brain scientist, really. So he does work in biology, and I met Venki when he was busy, very passionately, and with great diligence, taking undergraduates to Bangalore to give them exposure in science in different ways. I went to high school in Bangalore, so we had something in common, and I convinced him to come to the SAI meetings, and over time he's gotten roped in more and more. And now he and I have been trying to put together this so-called B4, which is an awkward acronym, but I'll let Venki explain it and then elaborate it and talk about the science portfolio, or some of the science portfolio at SAI. And maybe Venki can introduce the others. Yeah.
Well, thanks for coming. So I guess the goal, in some sense, for this panel discussion is essentially to think about, like, what if you wanted to actually go to South Asia and do research, teach, anything to do. Let's focus on life sciences, right? If you want to do why couldn't we just drop everything we're doing and just head off and do that? Like, what are the challenges? First of all, why should you do it? And why are we targeting this particular audience, right? I mean, why are we, is it just the people who came here from India, being educated, coming here, and then like maybe there's some connection back home? Or what if you're just interested in South Asia and you also want to have a profession, for example, right? There are many ways in which you can go back. So a lot of the time you'll see that people, let's say, coming from South Asia, at least in my generation, typically tended to go into professional schools, right? I mean, even if you do an undergrad here, you're typically going off to be a doctor or a lawyer, and maybe as of last 15, 20 years, maybe you're going into finance, right? I mean, professional. There is also actually a very large, it's an increasing number of people getting into research either in the academic environment or going into an industry in the corporate world. So the point is that there are a lot of opportunities. Once you come in, you're doing an engineering, I did an engineering degree, and then at some point I got interested in life sciences, brain science, and all these opportunities. And then the question we can ask is that, is there a way, first of all, is this beginning to happen in South Asia? I mean, India is what I know, but other parts of South Asia. And if not, are there structural impediments? Are there cultural impediments? How do we think about that? And more importantly, is there anything that, for me personally, is there anything we can do in a non-condescending way, right? I mean, going and educating and helping, sending people over, bringing people from there over here. So the larger question really is that first, how do we engage and promote in a scientific enterprise, both teaching and research in India? And of course, the applied part of it, like what are the needs? What do we do? Do we need yet another? I can tell you, I personally think we don't need yet another social media app. I mean, that's probably not what we would want people to go do. But do we need yet another low-cost glucose monitor, for example, for diabetics? Because it's obviously an increasing thing in India. So those are just one specific example. So generally talking about challenges and opportunities. Let's not just be negative in what are the challenges. And also, maybe in a larger point is that how do we, just even make science in and about, say, South Asia something interesting? To give one example, what do we mean by that? I mean, there's obviously in humanities a lot of studies about South Asia, the culture, the religion, and so on. But what about population biology of South Asia? Because we all know, just looking, phenotypically looking at people, that is very diverse. So what about, what is the genetic diversity? Is it first of all worth studying? I mean, there may be some cultural issues, people may not want to do that, but it's a very diverse, very interesting, there's a lot of migrations, a lot of intermixing. So just studying about the region from the population biology point of view. I mean, I actually don't think that it's even being led by people of South Asian origin. Interesting. Like there's a David Reich in medical school here, has actually beautiful work looking at the genetics of the sort of the South Asian people. So that's one example of where you can bring science about South Asia, not just doing in South Asia. But for today, maybe we'll talk a little bit, maybe more focused, the discussion on just opportunities and challenges of doing science research and education in South Asia. So that's all I want to say in terms of introduction. It's very general. Hopefully the conversation will be driven by obviously the specifics of what people the individuals here on the panel care about and know about, but you can move on to other things too. So I think in maybe relatively arbitrary order, I was thinking that we could, I would introduce basically more or less the people and where they're from, and if it's okay, you can tell something about yourself that you feel is good for this audience. So perhaps I would start with actually one sort of our guest, Muhammad Zaman, who is actually a professor at BU and spending, I don't know, is it just this term or this year? This term, supposedly doing a sabbatical here in the South Asia Institute, although I'm not sure he really disengaged from his other obligations. But maybe Muhammad can get us started.
Sure. Thank you so much, Venki. Venki and I know each other not only because of the Harvard connection, but also because we serve on the panel of a very exciting grant mechanism called the Smith Foundation. I'll come to that in a second, why I think that's something relevant for South Asia. But it's really a pleasure here. So I grew up in Islamabad. My family is based originally from, my father's side is from Lahore, but I grew up in Islamabad. I came here for undergrad. And science is something that I do. I'm a professor of bioengineering, but I also have an appointment in the School of Public Health. And the reason I'm telling you that is because I think, as Venki said, the public health questions are of tremendous importance. So it could be non-communicable diseases, it could be the issue of antimicrobial resistance, it could be issue of health and environment, it could be water and hygiene, all of those kinds of things. The fundamental challenge, and again I know Pakistan a little bit better than India, is that of sort of silos that come from the colonial era. And that is the fundamental challenge, right? So what that means is that at the end of your 12th grade, which is end of high school, or at least actually the end of your 10th grade, you either become sort of into the pre-engineering group or you go into the pre-medicine group. And the challenge with that is that biology and mathematics are not taught simultaneously. So if you wanted to be who I am, bioengineer, there is no way to do that, right? So that's a silo that you have created, forcing people, and there's a new recommendation is that even take biology away from 9th and 10th grade and start with computer science. So you have a generation of very smart people who will never see biology in their whole lives, right? So you're creating this cadre of people coming back from the colonial era where you have silos, and that sort of really affects your science conversation. So that's the first challenge. The second, and it's very hard to sort of change it at the later stage. The second challenge that you have is that of public awareness of what science really means. So who is a scientist? And how do you think like a scientist? The scientists would never take courses, or engineers would never take courses in sociology or anthropology. The anthropologists would never take a course in science. So there's a very complex challenge that emerges with awareness of what science is, what science means to the society. And then going back to Venki, somehow this whole notion of IT and app has had a monopoly on science. So technology means cell phone, and that's it, right? It starts with an app, it ends with sort of big data, and that's about it. And that not only is naive, that is extremely dangerous, and that it goes all the way to the government level. When they say we want to invest in science and technology, they mean more software parks. That doesn't mean new understanding of biology. That doesn't mean a better understanding of environment. That doesn't mean new technologies that may have applications outside of that. So that's the second challenge. And the last thing I want to sort of say is that I think, as it is true everywhere, and certainly it's true in Pakistan and India, the students who are unable to sort of break that mold are often stuck in that environment and are unable to really do that. There are many examples, including here at Harvard, people who come from Pakistan, from modest families, or perhaps even low-income families, who are able to sort of bypass those barriers, but most people are stuck because the system is actually very strong. So how do you sort of really unjam that system? One way is to have incentives. So this B4 thing is an excellent example where you would take people out, expose them to a different environment and allow them to really make a difference. The other way is to really force within the system where scientists and engineers have to work with social scientists and humanists and public health professionals together through some kind of pilot or seed grants and things like that. And then have some mechanism where there is high-risk research done. And that is why I wanted to come to this Smith Foundation thing, which is not about sort of doing more of the same, which is not about doing something that would get funded from federal agencies. It is about doing something that would probably not get funded by federal agencies because it is so out there. And you really need to seed that at multiple levels. So I'll stop here. I'm happy to have this conversation sort of reach some kind of an equilibrium where there's a little bit of back and forth. But the last thing I wanted to add is I'm on the board, just for sort of complete transparency, on the Science Advisory Group for Lahore University of Management Sciences and their School of Science and Engineering. And there, in a small way, we are trying to address these questions, making sure that our engineers take literature courses and ethics courses, and our non-engineers and scientists also take that. And even within that environment, it's not easy. So Usman is sitting here. I mean, your engineering faculty takes pride in the fact that your students don't have time to think. Literally, that's what the Dean of Engineering said, that we want to burden them with courses so they don't think. Right? So these are the challenges that you deal with. And it may seem absurd and naive or horrifying, but this is the reality in which we need to operate if we want to change the culture of science.
Great. Yeah, I think again, that's wonderful, because I think we just want to get a specific conversation going, and then hopefully it's more back and forth as we go. So, yeah. Okay, so the B4 is the program. So it stands for Boston, Bangalore, Biosciences Beginnings. Hopefully at some point it'll be continuings, but anyway, we'll see. Never ending. Yeah, it would be good. B, I don't know what to call it then. So, yeah. So the general idea is to have a two-way exchange of scholarship, essentially, of students mainly, maybe a little bit of faculty as well, between Bangalore, just because that we started that hopefully you can expand to other parts of India as well, and Harvard, like the system, and it doesn't have to be just Harvard. It can be BU, MIT, sort of the Boston area. And concretely, what is it? There are two aspects right now which we can expand. The first aspect is we raised, actually, largely thanks to Tarun, raised money from the government of India, actually, Department of Biotechnology, as well as the government of Karnataka, the state, to fund up to five, and hopefully we want to expand it, fellows who have just completed their PhDs to come and work in a laboratory here in the Boston area, unfortunately for 1 year. Unfortunately, because I think much longer would be much, much better. But idea, in fact, Parvathi, who you will hear from, is one of those B4 fellows. We have 5 fellows. Unfortunately, one of them somehow couldn't get his visa, so it was really unfortunate they couldn't come. But so they will come and do a little bit of research, and they go back to India and hopefully continue this collaboration. So they will be the thread now that would sort of link, and this then hopefully will be amplified. The other part of it is faculty from Harvard will go and do sort of 2-week-long courses, winter, summer, whatever, essentially trying to address some of the things that Muhammad brought up, which is that a lot of the engineering students have never heard of biology, or if they do, they heard of it in a bad way. So what if we have a course which basically says, like, I'm going to tell you about neuroscience, and we're going to target engineers and math people. Tell them, look, first of all, it's quantitative, it's rational, and it's actually exciting, because all the AI stuff that you keep hearing about, deep neural networks and all of this stuff, has actually pretty strong links to neuroscience. And actually, we did one of those last December, and I think it was actually fantastic. So there's sort of the two-way thing where we kind of go and do courses and things that students would normally not hear about, or normally they would mix, and then also bring fellows. So that's basically, and it can be expanded, and given enough resources, I think many, many directions to expand. We could bring more people for a longer period. Maybe we can have something that's very overtly translational, for example, right? Maybe you do explicitly with some internship in a biotech company, and maybe encourage people to do startups and things like that. So that's basically the thing, and I'm happy to answer more as we go, just to give you an idea. That's when you say B4. In fact, there are 3 other B4 fellows are actually sitting in the audience there. You can say hi to them at some point. All right, so I think we'll go, maybe on that note, maybe we'll get Parvathi, who is one of the B4 fellows, to tell you a little bit about your background and sort of, get some conversation started before we go to Conor.
Thank you, Venki. So I would like to start by saying that thinking is basically manipulation of information, like wherein you try to develop concepts or ideas and then try to identify maybe a problem which arises out of that, and then enter into problem-solving mode, then maybe reason, and then find out maybe a solution to it, like make decisions based on the reasoning. So whatever I'm going to speak now is basically a thought process, like connecting facts which I had in my mind when I thought I had to speak in such a forum. So I need not introduce myself, as he told that I am a technical fellow, and with 4 other fellows here, we are like greatly honored and happy to be here as part of this fellowship. And from my perspective, I think that it's a very enriching experience in the background of the fact that I completed my master's and PhD in agriculture, specializing in crop physiology from the University of Agricultural Sciences, Bangalore. In the backdrop of the fact that the main theme of this symposium is migration and transformation. So this fellowship basically advocates it a lot. So I would like to say migration and transformation from 2 different perspectives. Maybe there are 2 realms of it. The first being that considering our own situation where young emerging researchers are given opportunities to come to a scientifically rich environment and allowed to imbibe new skills and then get transformed so that it is translatable. What I mean by saying is that, like, go back to your own niche with whatever we have imbibed and then try to materialize it or implement it in the way you want to at any scale. So that's one perspective. The other perspective is about migration and transformation in the background of not having enough or satisfying kind of opportunities, which like instills in you like an urge to migrate in order to transform, probably. So if I consider these 2 perspectives, I give more weightage to the first perspective. And I'm like very glad to be part of such an initiative from the Government of India and Government of Karnataka. But if you think the second perspective as an apprehension in the making, like are the other migrations and transformations happening due to lack of opportunities? So when I say lack of opportunities, I do not mean to say that there are no opportunities. It's basically because of the fact that you should be able to try to have more creative possibilities and maybe get attuned to that, like coming out of the the boundaries of certain stereotyped or cliched opportunities, which you would think, okay, I have just 5 different opportunities, so I want to just go in these 5 paths, but then maybe all the 5 paths are like maybe filled with a range of cars which is in a traffic jam or something like that. I mean, I don't know how to visualize that, but it's the thought which I have in my mind. So any PhD, especially in the agricultural academic sector, any person who completes a PhD and comes out has a very big question in front of them. So what next after PhD? Okay, you go into a postdoctoral position. Okay, what next after a postdoc? So that's kind of a very emerging, scary question which comes in front of all of us. At least it's from my perspective. When you take the science sector as such, you have ample opportunities in academia and industry, but each one is weighed in a different kind of, the yardstick and the scaling is kind of different. So, because I have personal experiences, like close interactions with people who have completed 5 to 6 years of postdoctoral experiences in elite institutions and come back to India and struggle to mark their place, like make their presence felt. And I've also interacted with people who just become judgmental of the fact and they just take drastic decisions of science doesn't give me a career, so I'm just switching over to something, and they just end up doing, although they are like very good and bright. So that's kind of a big concern. So in front of all of the PhD students, I think this is kind of a very big uncertain question which comes, which is also being debated recently. And in one of the recent publications which came from the Elsevier Publishing Group in 2017, they say about they express or depict this as a measure of evolution in the ratio of faculty positions to that of the PhD students getting graduated. And I mean, this is a study which was conducted in Flanders in Belgium. So they say that about 32% of the students, PhD students, like enter into some kind of a depression because of many anxious questions in front of them, among which a perception of a career which is other than academia is like a major serious concern for them linked to this depression. So I think it explains it to an extent. And in the Indian context, especially in the agricultural academia sector, if I would want to say, each state in India has a state agriculture university. And the state agriculture universities are coordinated by the apex body, the Indian Council of Agricultural Research. And each state agriculture university at least has, on an average, like 2 campuses working under them in a state. So you can just imagine the magnitude of the workforce or the students who get graduated as bachelors of agriculture, and a proportion of them go on to do masters in PhD, like coming into the elite qualified sector, and what are the opportunities that we have to give them. So I thought I would like to express this concern in an audience like this and try to think collectively whether this is a, this has been occurring from a long time in different sectors, or is it just emerging as a serious threat recently? So I just thought I would want to discuss. But I didn't want to be very pessimistic, so I would like to end on a positive note, like pitching on 2 aspects. The first aspect being, recently there have been a lot of demand to discuss about women in science. And I'm very happy that as part of the B4 program, at least 3 out of the 4 of us here are women, and I think it's very promising. And the second aspect being that this actually forms a good networking platform, which has high potential. I would like to draw your attention to another personal experience that I had, because during 2014-15, I had the opportunity to be funded by the European Union as a part of a India-EU mobility project called as a Namaste project, wherein I had the opportunity to spend 6 months of doctoral research at the University of Groningen in the Laboratory of Plant Physiology in Netherlands. And that was the initial cohort, like as I am part of B4 right here now. And during the second cohort, based on the performance, my PhD supervisor got the chance to go in as an academic professional mobility for a month in the same lab. And that really created a good foundation for collaboration. And it developed into a memorandum of understanding between the 2 universities. And this year, I'm very happy that the first student, the PhD student, is going from University of Agricultural Sciences, Bangalore to the University of Groningen. So I consider B4 program also as such a platform. So it has high potential, and it would form the basis for a strong foundation for collaboration in future. And networking, I believe, is one of the crucial keys to progress in science. So thank you.
Cool. Thank you. So and then finally, but Conor Walsh is actually a professor in the engineering school here. He's kind of a robotics person, if you were to put sort of a label on him. And Conor's here because, not only because he does wonderful science and engineering, but he's actually gone to India, to Bangalore particularly, to work on some very interesting engineering projects. And I think he has a terrific perspective of what you could do, like why he finds it rewarding and what you could actually contribute, even if it didn't have previously any ties with South Asia in particular. So, Conor?
Good, thanks, Venki. Yeah, so I'm a faculty member here at Harvard in the School of Engineering. I've been here for about 5 or 6 years, and almost since I started here, I've been talking to Meena and Tarun about opportunities for kind of getting involved and doing work in India. And I had visited India one time before I started at Harvard, and I guess I was just struck from the enthusiasm and the intelligence and kind of the motivation of the people there that I met with. And it was just a really interesting, eye-opening experience for me. And so here at Harvard, one of the things that we do is we try and work on very translation-focused problems. So kind of problems where, that we identify either through collaborations with clinicians or by talking to companies that there's opportunities for innovations and developing new technologies that we think can help solve a problem and not just be an interesting scientific paper, but eventually kind of go on and have an impact in the world. And for that last part, that's hard, but how you get a technology from an academic setting out into the real world involves either doing a startup or partnering with a large company in some way. And so, for me, I agree with some of the comments that were made in terms of, IT and apps. I think I'm a hardware person. We build hardware, and we don't just design software. I definitely think that's an area that, not just maybe in India, but even in the US and other parts of the world, has been underappreciated, over the last 5 or 10 years as we've seen this kind of IT revolution take off. And IT revolution's been fantastic. I just think sometimes people forget that there is hardware and there's opportunities there as well. And I think that the interesting thing there is it's about what materials can you use, what manufacturing technologies can you use that lead to kind of new approaches to doing things that maybe we haven't been doing before. So in our particular research, we're working a lot in the field of soft robotics. So you think about robots traditionally as devices that are in a factory and are kind of like moving things around or painting cars. We're thinking about soft robots that are made out of soft materials, silicones, elastomers, textiles that are safer for interacting directly with people. And so I think, for me, a big part of, what I heard in terms of exposure, I think, when I visited India, it's clear that if you can put the examples to people of what's possible when you think about things in new ways or you combine disciplines in non-traditional ways, people get it really, really quickly. So I think one of the things that we're interested in doing going forward is more in an educational context in India. How do we kind of leverage some work that we've been doing here to develop outreach materials for soft robotics and be able to kind of develop educational programs that could be run in schools, or people on their own could just do them at home, that would kind of inspire people to get involved in science, technology, engineering, and math. And I think in India, probably in particular, there's already a lot of people who are very excited about that. But I think the advantage of kind of this, soft robotics outreach effort is that I think it makes people appreciate the hardware aspect a little bit more as well. So we kind of like to solve problems by working with clinicians, and we also, are excited about encouraging people to get involved in this area. And so in 2012, we ran a program with the South Asia Institute where we had a number of Harvard students, so an engineering student from the Kennedy School and Business School, and a student from the college who basically went to Naharanda Hospital with Dr. Devi Shetty in Bangalore, and they basically went in and observed different procedures that were going on. They talked to a lot of doctors, and they tried to understand what might be some opportunities for working on interesting technologies or projects there. And I think part of the goal is to help think about, is there an opportunity for something new? And that would be great, and that would be like a real home run if you succeed in that area. But I think the kind of probably the primary mission of programs and activities like that is to kind of expose students to kind of like different environments, get them thinking in different ways, get them to make connections with different people, and also kind of build relationships. And so we teach similar courses like that here at Harvard, where we have our engineering students work with local clinicians from local hospitals, but trying to get our students to work on more real-world problems where it's not basically a textbook where there's a right or wrong answer. They're very open-ended, there's no right way, and they're hard. But it's kind of by going through that process and doing it while you're a student helps you then think about how you might do something like that when you graduate and when you leave. So you kind of got this low-risk environment to kind of do those types of things. And then for 2 other summers then over the last few years, we've also partnered with the Indian Institute of Sciences in Bangalore, where we've had a group of students, again, largely from the college, and some C students, be able to kind of go there and work with 4 or 5 master's students or undergraduate students there in the mechanical engineering department. And they basically did the same type of thing, but kind of, more kind of with a joint team. So it wasn't just the team from Harvard going there to do it, but it was a joint team. And I think that, was also interesting because apart from the, experience of going somewhere different and the experience of working on this project, there's also kind of the cultural exchange where, these students are getting to know each other. And the students from Harvard are getting to learn about everything that goes on in India. And the students from India are getting to learn about what's going on in Harvard or in the US. So I think trying to do more of those types of things is something I'm really interested in, and trying to figure out like what are the right institutions to partner with, how do you engage more with governments to support those types of things. And that's all really, really interesting. So that's more on the educational context. And then more recently, the School of Engineering has also, and the Office of Technology Development, started a partnership with Tata. Tata Communications, I think, is the main company, but really around how do we actually kind of think about some of the robotics work that we've been doing more in a research context and start applying that to other areas. So, Tata has lots and lots of factories. They have lots of workers who are working in those factories. And so we've been focused mainly on medical applications of our wearable robots so people who have suffered a stroke or spinal cord injury. But can we also think about applying this to kind of workplace safety and helping to kind of reduce the risk of injuries or improve safety with wearable technology for people working in factories? And I think, to me, it's been really inspiring working closely with some of the people at Tata, because they've basically identified this opportunity, and it's not just an Indian opportunity, it's really a global opportunity, but they're a big enough company and they're forward-thinking enough that they see this opportunity. And I think, after we do something with them, I'm sure it can kind of spread to many other parts of the world, and it won't just benefit workers in India, but in many other places as well. So with that, I'm happy to kind of conclude and then discuss more throughout the panel.
Great. Well, thank you. So I think at this point, I think we can basically free-form discussion. People have sort of questions, and I think we should start with the audience. Yeah, and yes, that's true. Actually, it would be good if you can briefly also introduce yourself so everybody else knows approximately who you are.
Hi, I'm Usha Nesamoni. My husband Diaz and I are really interested in sort of work in India, and we have a foundation that is focused on sort of, if you will, the broad goal of eradicating poverty in India. So that's sort of our primary goal, and we support in various different ways. But Conor, one thing that you mentioned, I was thinking as you were all talking, is the leverage that India brings, as much as sort of Harvard and the research going and helping folks in India, the students and the faculty, what you said about sort of Tata and whatever they do can also help the world. I was just thinking, there are concepts like Jugaad, for example, that's very sort of, it's full of creativity, right? Resilience and solving. So I was just wondering, what sort of programs do you have for sort of the reverse way as well, not just one way?
I don't know. I don't have anything specific for our part. So by reverse, do you mean like having opportunities for people in India to contribute towards this way, or what?
Or skill sets, or mindsets that are very sort of that is very.
So transfer that to yeah. It's a good question. So I think that's hard. I think for me, just my personal view is that I've been very careful not to. In either direction, not to have any sort of hierarchy in some sense, right? I mean, not to say like, I know this thing better, I'm going to teach you, this. So I think the way I would imagine is that maybe this B4 program, I could imagine putting it in that context, like, they're coming, so like, for example, Ramya is coming and she did sort of mathematical biology, and then you come here and, maybe there's a certain aspect of maybe mathematical sophistication among students in India who happen to have also done biology, may be very different from people here where like a lot of the biologists are very, very averse to math. So maybe that sort of comes in. So that's a very specific example, but I think for myself, it's thinking a little bit more organically and haven't thought, but maybe these others have thought a little bit more about how to harness that, so to speak.
Yeah, I guess I totally agree with you that it goes both ways, but I think it is hard to generalize and say, how specifically should you set it up to kind of make it do that. I think, any of our students, like thinking about it from a student perspective, working together, I think the students from Harvard learned a lot from working with students like on the ground in India, so, in terms of engineering skills. So I think it's, both on a one-on-one level and on an organization level, I think it definitely goes both ways. And I think, that's kind of partly where the excitement is that, it's a different perspective and different expertise. And, when you're kind of collaborating with someone as an academic, the last thing you want to do is collaborate with someone like yourself, because you want to collaborate with someone who is actually the inverse of yourself and someone who's really different. And so I think, in my experience so far, I've always really enjoyed that different in perspective and different in training. If people are trained there differently too, they think differently. When I gave a talk, at a Tata event last March, I got questions that were very different than questions I would get here, just because there's a different perspective, different training. And definitely I think on the mathematical side, I think people in general, I would say, are stronger in India, when they've gone through the educational system in math. And I found the questions being much more theoretical focused compared to questions that I would normally get here. That was one difference that I noticed. Yeah.
No, I think this is right. I mean, I want to answer that question in two ways. So over the last year, Tarun and I have sort of thought and looked at sort of this concept of reverse innovation as well. And it seems very powerful and promising, but it's it's quite challenging, not to say the least, because of what Tarun has sort of coined the term of contextual intelligence, right? So the context really, I mean, you can have a great idea of jugaad or something like that, but that, the application of that in Boston is going to be very different, needs to be locally evolved. You cannot take the Bombay or the Bangalore idea and sort of just transplant it here, and that just doesn't work. So I think Venki's point is very well taken, that I think it has to be organic in terms of that growth, and that is I think where the richness is, in having a little bit of every idea taking a life of its own in some kind of way. We certainly see that in terms of how people look at that. That's not to say that there's not important lessons to be learned, and I see a couple of my students are here, and we do a similar program as what was mentioned, but not necessarily in South Asia. I take my students to East Africa, and they spend 6 weeks there, right? So every summer they go there for 6 weeks, they live with local families, they learn Swahili in the morning, they visit hospitals, and then come back and sort of use that kind of training to develop new technologies. But it's really organic of how they learn, and sometimes they go with certain notions that I'm going to build this technology and do this, and they come back and realize that none of that is going to work. In fact, the need is something else, and the ideas have to be flexible. So I think this idea of cross-disciplinary and cross sort of oceanic idea movement is important, but I think it has to be done in a very nimble way and a case-by-case basis, as opposed to sort of something that is codified in stone.
Some engineering colleges have an ethos of make their students work so hard and they're so busy that they don't have time to think.
Yeah.
And I think that's quite an incredible statement to make, if anyone whoever made that.
Yeah.
How do you think we can change that, and how do you
allow
engineering students to think? And
So,
who was this person? If
it's a great question, and it's well, I mean, I think there are many. I mean, it may be one individual, but I think that mindset is actually quite present. So, among my many sort of random activities, I write in the newspaper every week in Pakistan, and every time I would argue that there needs to be more sort of relationship between science and engineering with social science and humanities, there's an aggressive pushback. Why do we need this, right? So we were good enough engineers and scientists without doing this, so why do you really need to do that, right? So this mindset does exist. So when I talk about jam system, that is really jam in terms of thinking and in terms of sort of real actions. So people would be convinced, perhaps, maybe not, with some real evidence that this is really helpful. And that's actually not that easy, to demonstrate that taking a course in Punjabi is valuable for an engineer, and thinking about sort of ethics of feminism is relevant for a civil engineer, right? So why is that relevant? And I think that's a hard question. And you cannot come up with a top-down approach that because I happen to live in Boston, I know your answers, and hence you should take the same course that everybody at Harvard is taking. That argument is not going to fly, and that shouldn't fly. So I think I don't have answers, but I'm just saying that it is actually a challenging issue, and at LUMS, where I'm involved, we've tried to do that a little bit. And it does work reasonably well, but not without a pushback. Because the argument is, what is better, to take a course in a language that is spoken by 15 people, or take another math course?
Sorry, I just wanted to add a little bit, because I know the gentleman that Ahmed was referring to.
Zaman is going to reveal her sources now.
No, so part of the problem is cultural, right? This tendency to over-specialize. It's a demand that parents make on their children. If you're going to study engineering, why would you want to take a course in the social sciences or in literature? So that pressure definitely still continues, unfortunately, at the parental level. And then again, so the old school of teaching also then reinforces that bias. And part of the problem is regulatory, actually. So one of the reasons why we have to conform to this at universities in Pakistan is that the Engineering Council will not recognize a degree unless it gives, in electrical engineering, for example, unless it has a certain amount of coursework, and it's a ridiculously high amount of coursework in that particular discipline.
That's an excellent point. The regulatory issue, and that's true actually in medicine as well. So I know that a little bit because I was working on a project. You can become a doctor in Pakistan without ever taking a course in immunology, in biochemistry, in cell biology. So if you want to talk about, for example, the issue of antimicrobial resistance, or you want to deal with HIV, a doctor has no training, not because he or she is not smart, But the regulatory system is such that they have never been exposed to a course in immunology, ever.
No, I know exactly what you're talking about. I mean, I had a CEO of a tech company from India who told me that they're having a challenge. That they're having a challenge finding employable graduates from engineering colleges, this is especially in the IT sector,
Yeah.
that have people skills, that can communicate with clients overseas at Novartis and Boeing, et cetera, and be productive from day one. And I think that's what happens when you teach engineers only academic and technical things and not expose them to other things like, be member of the debate society or some humanities or et cetera. And that creates this sort of gap in the development of their entire personality where they don't have the people skills needed to succeed in whatever sphere you are, whether it's academia or professional engineering or the corporate sector. And so we actually started a program teaching emotional intelligence and leadership to engineering students in Bombay. I have an educational startup that we were doing this. But I know the point that you were making, and it makes
I would also just add that we could also be having this conversation in a School of Engineering faculty engineer meeting at Harvard just up the street. This kind of challenge of like what courses should engineering students take is still something that we're debating here, and I don't think we have consensus in terms of what is actually best.
And it's ironical that now we're trying to create robots who can think.
Well, you can make humans into robots. Perfect.
But I do think it's changed a little bit. I think now the importance of higher degrees is kind of changing things a little bit in terms of what should you be most teaching in undergrad, because before an undergrad degree was supposed to give you everything you need to know in order to kind of to graduate. But I think now that we have masters, that's more and more common both in Europe for engineering programs, and it's maybe not as common in the US, but I think it's increasingly common that people get a master's degree, and then even PhDs and higher degrees. And kind of to your point, Parvathi, in terms of like what's next for someone who gets a PhD. Academia, there's probably limited spots in terms of if everyone gets a PhD, not everyone can be a faculty member. But how do we also make sure that it's that end of our higher education system is not just having people go to graduate school to become faculty members, but there's tracks and programs for people who want to take a non-academic track, and they're getting other courses in entrepreneurship or business or other things along the way, so that they can both have a strong technical background and then those other skills that they would need to kind of pursue whatever career path they would like.
Yeah, I would also like to add a valuable point to this, because I would just like to say about the structure of the agricultural course as such, the Bachelor of Science in Agriculture. So it's a course encompassing like all different subjects, starting from maybe you have mathematics courses, you have economics courses, you have extension, you have psychology. So it's a complete course in the making, maybe the graduate who comes out, because at the end of the course, you are really equipped to decide what field you would like to see, you would like to take. Is it like hardcore research? Is it agricultural policy research? You want to go in Master of Business Administration? You have agricultural business management courses. So what do you want to take? So I have seen that kind of a curriculum helping students to edge over many others in different skills they acquire during the course. So it's a 4-year course, and around 166 credits are there for the course, which you complete at the end of it.
So in some sense, we're preaching to the choir, right? Because many of us recognize that this over-specialization, while it came out of a particular milieu, it has its costs. I think the onus is on us a little bit to explain why exposure for an engineer to the humanities is useful. And I don't think we've quite crystallized it beyond simply asserting with increasing vehemence that it is, which is not going to cut it. Yeah. So one of the approaches that I've adopted in my course in the college is to basically try to articulate this to myself. And I'm the first to admit that I don't know how to do it. And what we do, I was mentioning it yesterday in some context, what we do is we take, I refer to them as intractable problems of economic development, and say, if you had to approach this problem as a scientist, how would you tackle it? And there's a so-called scientific method, which philosophers of science have debated endlessly what it really is. But the idea of generating hypotheses and testing and when do you stop and what knowledge bases you draw upon, there's a set of, if you will, gimmicks in science that you use at an abstract level to attack any problem. And if we sufficiently abstracted, the problems of all these four scientists would be similar modus operandi at some level of abstraction. Then we get artists into the class and we say, okay, it's the same problem. How would you think about this as an artist? And some of the artists role play the problem. Some of them put themselves in the shoes of the person experiencing, contaminated water or something like that, and say, this is what I would think about, these are some of the things. And they turn out just to be very different. Then we bring up, a planner or a policy person or an architect and so on and so forth. But what we're trying to do in the course through iterations over the years is to articulate what it is about the process of seeing a problem as a humanist or as an architect or as a scientist that causes you to approach this elephantine structure and you're touching different parts of the elephant as a proverbial blind person. That's my quest to try to articulate it better, because until we can articulate it, we can talk to each other all we want, whether it's in SEAS here or in Bangalore or Karachi. It's not going to make any difference. We're still going to have the onus on us to convince people why they should incur the costs of moving away from their system, which they have been ingrained into believing.
I would also say that, I think I've heard other faculty say, people are usually feel very emotionally strongly about how things should be taught, but cannot often articulate exactly why they want it to be taught that way. And so I think that's what results in so much debate, because everyone has very strong opinions, but it's sometimes you have to break it down a little bit more, and that's hard.
There was a question there?
Hi. My name is Ashish. In the context of this gathering, I have a complex relationship with the university, so I won't get into how I'm affiliated. But in a different capacity, I work in the UN system, and I've interacted with Professor Zaman there as well. So, there are really two trends here in this conversation that I'm catching on to. One is, the general conversation about super specialization and not having a diverse skill set within the field of science and technology. But another application of that, which you'll see at the UN in 2 weeks, is that the conversation within science and technology as well is being extremely skewed towards what the perception of science is and what kinds of investments entail meaningful investments in science. So, of course, there are avenues to push back against this, and they have not been as successful as one would have hoped if you're on this side of the thinking. So, what is the approach that you have tried to use, at least with, governments, funders, the private sector, on the education side, we at least know, that we have to make the case, we understand what the problem is and this and that, and it's an uphill battle, but it's a known issue. So, how can that be expanded in the context of, And when I said in 2 weeks at the UN, it's the Science, Technology and Innovation Forum for the Sustainable Development Goals. The UN is finally catching on to the idea that science is an enabler to achieve sustainable development. So I can talk more about that with everyone later, but just wanted to bring this up.
I think that's a great question, and I don't know if I have any answers, but I think this idea of enabling a countrywide science policy is both attractive and fraught with all kinds of challenges, right? So I'll speak in the context of Pakistan. So I was there last month having a national meeting on sustainable development goals in the context of health. And almost exclusively, the conversation was on implementation. None of it was on discovery. None of it was on local capacity building. It was basically, how do you take existing solutions and make sure that you decrease inequity based on vaccines made in country X, technologies made in country Y. So that conversation, that connection hasn't happened in a rigorous way. So science is in its own domain of sort of greater good of society, but sort of that connection that this is really an enabler in society really hasn't happened. And there are many reasons for that. Your institutions are not necessarily strong. The translational pipeline to make an impact from science to what Conor was saying, to make a technology that works in the system hasn't happened, all of those kinds of things, right? Even in Pakistan right now, if you were to look at where the technology is making an impact, with the exception of few apps, it's not indigenous, not at all. And there is no effort to indigenize it either. So that changes the conversation completely, which means science is the hobby of few crazy eclectic ones who sort of want to think about infinities and sort of dark space, but not really sort of making an impact on society. And that hasn't happened. And I don't know how that would happen, but you're really sort of putting a finger on something. The only exception is in agriculture, which that case was made early on in development that this has to work. So Pakistan, for example, has a fairly well-established agriculture institute. It has strong connections to the power brokers in the military, in the Atomic Energy Commission, in the government, and all of that. So that has happened. But broadly speaking, certainly hasn't happened in health. Certainly hasn't happened in water other than dams. So that connection hasn't been made. And I think that's a question one has to ask is, what is the future of science in South Asia, and who would make those connections?
My name is Ajit. I live in the community here. I think of 3 issues. I'm going to try and squish them into one. Parvathi, my information tells me there are 15,000 a year agricultural graduates, and if I may exaggerate, nobody goes into agriculture. In the engineering colleges, the 2004 study, I think, showed 2,500 engineering colleges graduating 500,000 engineers, and only 30 to 50 were of decent quality. And the rumor was half went into MBA, half went into nobody stayed to study and do PhDs. So the lack of PhDs. The proposal was made to the government, pay people to do PhDs. And I think the IIT at that time was charging 35,000 rupees per year, and the cost was 70,000. So the proposal was charge 1 lakh, take the difference, and half to pay. It was turned down. If we're not creating PhDs, how is the quality going to improve? Number one. Now, on the other side, there are 3 things we like. We like cricket, Bollywood, and studying. Everybody studies. I've never known a culture to study as much as we do. I mean, you go to Latin America, they dance, they sing, we study. Okay? Even a 4th grader, 100 sums every day, sit down, parent will sit down. Book chahiye to bolna bachcha. Kya chahiye? Kathi roll chahiye? Driver ko bhejta. You have to study. We've got the potential. And last fact I'm going to put, the College of Engineering Pune, I happened to be there a few years ago, and D-Lab from MIT was there with 75 randomly chosen kids. 4 days they had to go identify a problem, solve it, make something to, and there was nobody to listen to them. I happened to wander, they caught hold of me. Uncle, come here, see what I did, see what I did. I saw blind people. I was totally amazed what was there. So answer this question. If there is this kind of ingenuity at the bottom, people want to study, what is holding them back? And if it is the curriculum, I'm sorry, one last fact. I happened to go with a non-profit that was taking Indian expats from here, who are on top of their field, to India, collected 900 teachers, and showed them what they were doing, the latest in the curriculum. I was supposed to observe. I observed one, didn't understand anything. I was not smart enough to, but later on I wanted to know what they learned. And all of them said it was very interesting. I said, are you going to use it? And I don't. University sets the curriculum. So nowadays, if you've got this structural impediment, isn't that what we have to attach for? There are a bunch of brilliant Indians here, you folks. And yes, emotional intelligence needs to be taught. But in the bulk, how do you bring in the government into this? Shouldn't they be represented with you? कैसे न कैसे उनको पीठ में उठा के चलना पड़ेगा ना, नहीं तो काम नहीं होगा.
Great question. So I think, I don't know, you guys have, I think Tarun actually has probably some ideas because you interact with people in the sort of government and people trying locally to figure out how to do this. And I don't know, for me it seems like it's a massive problem of scale, right? I mean, it's like everything is sort of little autonomous, this and that, and how do you get everybody to? And I feel it's hopeless, but I think some other optimistic people should speak up.
So I have one small anecdote, which I think has a substantive point. This was just last week, and I was in Delhi for a day, and I had to give a speech to a collection of dignitaries of different sorts. And it turned out there were a lot of, the room certainly had super educated people. And the context turned to science. and science awareness and science literacy, and what sort of very similar to the to some of the last few comments. And I just asked the question in the room. I said, how many scientists are in the room? And there were no scientists, basically. And so then I said, how many of you have actually, in the course of your professional lives, in the last 12 months, had a conversation that had some scientific tinge to it, just a tinge, conversation about science with a scientist? And this included some recognizable corporate figures in India who run major corporations, major global corporations. The answer was zero. Nobody. Now, I just had the thought experiment that if I had been sitting at HBS and I asked a room of 50 CEOs, how many of you have had a conversation with a scientist? And the answer would have been 50 out of 50 would have had a conversation with a scientist, or much more than that, a very deep conversation. And the point I was trying to make on the fly was that there's this ambient lack of awareness of science that I think has to be addressed. Lack of appreciation of basic scientific literacy. You don't have to be a scientist, but you have to appreciate that ultimately knowledge comes out of science.
But it's not even appreciation, it's a definition, which just sort of goes to your point. Like, what is science, right?
Finish your thought, and I'll tell you another anecdote.
That's my...
So, there was... I wrote a proposal 2 years ago saying that let's have a program on science. Something that is not dry, but something that is engaging, right? Kind of a National Geographic rooted in our context, not sort of a dubbed in Hindi, because that defeats the purpose, because those people who are watching that can watch it in English and it wouldn't change anything, or dubbed in Urdu or something like that. And so I went from one TV channel, and there are probably way more TV channels now than there were yesterday and day before, right? So in Pakistan, it keeps changing and it keeps increasing. So I went from one channel to the other, and the producer would say, yes, it's a good idea. And by the time it would come to the business managers, they would say, absolutely not. Zero market, no advertisers, absolutely not. And we did that for a period of 6 to 8 months, and we said, okay, I'll come on my own expense, and I'll do it, and I'll work with you, and I'll find people. I said, not a chance. Because there is no market for this, and maybe there is a market, but they didn't have an idea of what is a science show. How do you weave science into a conversation beyond a shouting match on the latest political scandal that happened last night? So this concept, and I was just telling a colleague right before here, so I was at Harvard Hughes yesterday, and they just had, so they've started a new studio called Tanglewood, which is the idea is great production, science, good science for the masses. So they just released a movie, a real movie, with sort of the South African sort of high and mighty rock stars called Lucky Stars. And the movie is basically a movie, but the underlying theme is TB, right? So it talks about sort of how TB really becomes a problem in this rock star group, and sort of these are people of fame and all of that. And that got me thinking that we don't have that capacity to engage people in good science, and whether it is a Bollywood movie or a 30-minute show or something like that. And that is a problem, right? I mean, if you ask an ordinary Pakistani or an ordinary Indian what he thinks of science or she thinks of science, one, you'll get very diverse answers, and many of them are quite problematic. And we tried to change that, but there was a massive pushback from the channels. Absolutely not. So we even went to the state television, Pakistan television, which probably 3 people watched. And even they said no. So it's kind of sad, but yeah.
But I think going back to the original point, which is that this is particularly, I don't want to use the word depressing, but it seems at odds, where there's a culture of study. Right? It's not that there is, it's not the lack of perseverance, right? I mean, it's like people are willing to, but it's done for some externally imposed reason, perhaps, right? I mean, you're like, you have to be first, you have to go get a job, you have to, rather than, at some point there's a little bit of curiosity. And I think that's why I meant, like, when I said hopelessness, it's more that it's not clear that science is seen as a way of kind of, it's a intellectually challenging thing, and it's okay to do it, but also have your other thing, right? I mean, you can still be an engineer or whatever, doctor, and still do science, or even an artist. So I think that's why I think the institutional the change, I think all education is seen as professional education, right? Really, at the end of the day, it's for getting a job. And I think that, I don't think that's unique to South Asia. It's exaggerated extremely in South Asia. And I think that is a challenge. And I think the hope is, I am actually, frankly, of all my pessimism, I am hopeful because in the B4 fellows, in the process of identifying the people, it was quite satisfying to see these people are very broadly educated. I mean, they're bringing both biology and math, and their interests actually also in outreach. And I don't know about emotional intelligence, but looking at them, they seem to have enough of that, certainly more than me. So I think maybe there are pockets, and maybe it's somehow if you fertilize you guys, then you go back and amplify this, and that may be a start. Yeah.
The word is relevance. I'm sorry. The word is relevance,
Okay.
and I think Tarun, you used that last year with art. I have sat in Rajasthan with a farmer who's barely educated. He's doing everything right: crop rotation, water. He started telling me why he was organic. Kauni mutri, lasun. He told me what mixture. 32 days he has it. Everything perfect. I don't know where it came from, but nobody has taken a movie of his and taken it to others. And I can give you plenty. In certain school in Bombay, and they've actually got one room now with 20 experiments. And it was what Tarun and all teach me is you got to bring citizen sector, corporate, and government all together. And once they did, it happened. So there are 2 or 3 ways of doing it where there are actually seeds put in there. The key is how do you take those expanded? Perfect. And I think, correct me wrong, in the MIT open courseware, one of the most sought after courses is chemistry and cooking. And Pratham said the same thing. Why don't we teach the kids in villages what they watch their mother doing? When they're mixing atta, making roti, what is the science behind it, rather than ABC? And
if one could produce 2 or 3 engaging episodes that would satisfy, skeptical people's or critical people's smell tests of whether, I wouldn't mind watching 20 minutes of this because it's engaging and communicates something. My level of creativity is pretty dismal, but if I could find a creative person to do that, then I think that market can be created.
Absolutely.
I'm not so pessimistic.
And I am watching my time because I have to go to a thesis defense in 15 minutes. So, one of the things that we did, and I'm actually very excited, and that's where my optimism comes. This year, we, for the first time in Pakistan, had a science mela in Lahore, right? Thanks to colleagues at LUMS and Syed Babar Ali. And the idea was science on the street. It was defined on the model of Cambridge Science Festival. It wasn't as extensive, it wasn't a whole week long, all of that. But the idea was sort of bring your science to the street. And the first day, we had about 10,000 people. And about the same the second day. So, right, it was sort of very simple in a little, at the little sort of a playground. But next year, the idea is, right, the physics of biryani. And sort of that kind of stuff, and really sort of bringing what people care about, and people do care about food, and certainly in Lahore they care about food a lot more than they care about food, or perhaps they, anyway. But the idea is to bring, why does it take half hour and not 45 minutes, and why does it take this temperature and not that, right? Why does my water look brown and not white? And the absolutely, and I've said this to many people, the moment that I felt that it sort of clicked was when a little boy, probably 7 or 8 years old, told his dad that he feels like a scientist. Right? And that's really empowering to do that. Of course, there are expenses. Of course, it was a nightmare to organize and all of that. But the fact is that you could do that, and there was a massive interest. Right? This really pent-up interest of young boys and girls in all kinds of social sectors and coming from the inner city and coming from the affluent places coming together. And if you really are able to continue that, not just in Lahore, but other places as well,